Hello, today in class we will solve some more examples using our properties. But today, in the examples, we will change the base of the number, the base of the degree. Let's write down the following example. 9 to the power of 5. We can calculate the value of this expression, but in the assignment. We need to change the base of the degree. Change the number of the base. The base is the number 9. How can we change it? The thing is, 9 is 3 times 3. Don't forget to write down the exponent of 5. Why? Because 3 times 3 is the number 9. And in the example, we have 9 to the power of 5. So I'm going to write 3 times 3 is 3 to the power of 2. And the whole expression is a power of 5. I've changed the base of 9 to the power of 5 to the power of 3. Now let's calculate what degree we have. By rule of thumb, using the third power, we have 2 times 5. As a result, we get 3 to the power of 10. These conversions should be done when you simplify an expression. And now, let's change the base of the degree in the following example. The number 27 is a power of 3. We need to change the base. The number is 27. What base do we change it to? The thing is, we need to count. Let's try to change this base to the number 2. We should end up with the number 27. But if I multiply 2 by 2, that's 4, multiply by 2, that's 8, multiply by 2 again, that's 16, multiplied by 2 again is 32, I don't get the number 27, then I'll try to write the number 27 as the number 3 to a power. And then I have to do the math. And indeed, 27 is 3 times 3 times 3 and multiplied by 3. You always have to count and you always have to get a number. In our case, we needed to get the number 27. So 3 times 3 is 9 times 3 is 27. And then that's a number to the third power. But 3 times 3 times 3 is 3 to the power of 3. And that expression is still to the third degree. 3 to the power of 3 is 27, and 27 is to the third power. And then we see that applying our properties, we get 3 to the power of 3. 3 times 3 equals 3 to the power of 9. Notice there are a lot of 3's in this example, but each number represents a different position. The number 3 represents the base of the degree. And 3 times 3 is the exponent, which is the exponent of the degree. Next example. The number 64 is a power of 5. In this example, we'll write down the different bases. We will solve it in 2 ways. In the first case, 64 can be represented as 2 times 2 times 2 6 times. 2 times 2 times 2 times 2 times 2 is 8. Multiply by 2, 16. Multiply by 2, 32. And multiply by 2 is 64. And is a product of the fifth power. But the number of multiples of 2 equals 6. So I'll write 2 to the power of 6. And this whole expression to the power of 5. And then we have 2 powers of 6 times 5. And that would be 2 to the power of 30. But we can write 64 with a different base. 64 is 4 times 4 times 4 times 4. Let's do the math. 4 times 4 is 16. 16 times 4 is 64. And that's all the product of the fifth power. And then there are the 3 multipliers that equal 4 are 4 to the power of 3. It's all to the power of 5. And then you get 4 to the power of 15. In the first example, we got 2 to the power of 30, and in the second example, we got 4 to the power of 15. We can prove that the values of these expressions are equal. How do we do that? 2 to the power of 30. I can write it down as 2. What is 30? It's 2 times 15. And then it's 2 to the power of 2 and to the power of 15. And 2 times 2 is 4. 4 times 15. We got the same answer. The only thing is, in the first case, I wrote down that 64 is 2 to the power of 6. And in the second case, I wrote it down as 4 to the power of 4. And that's the number 64. How do I not make a mistake in changing the base? 3. The thing is, when I was recording 64 as the product of 2, notice 2 to the power of 6. But if you multiply 2 by 2, it's 4. So then I write 2 times 2 as 4. And then I write down 2 2s as 4. And then I write down another pair of 2s as 4. And then I get 4 to the power of 3. In the next lesson, we will solve some more interesting examples. And for today, our lesson has come to an end. Goodbye. See you again.